Now, there are two types of rock we need to characterize. One of them is the storage element to it. Call it a reservoir, because in oil and gas terms, that's where the oil and gas is held. And that, the illustration on the left is an example of that. Now, this image is taken with a very special electron microscope. Doesn't matter how that's collected. But the key thing is the white motif here. You can see the key down here. The white is pore space, porosity. Now, mostly in the subsurface, the porosity is filled with water. We want it to be replaced by carbon dioxide, but we need a lot of it. We need a lot of porosity. Otherwise, there's no point trying to squeeze carbon dioxide in there. So the other minerals that are present, that's quartz in pink and the mauve color, which I'm colorblind, actually. I really shouldn't be doing this, but the mauve color there is natural calcite cement. That's what makes it a rock, not a friable sand. So there are other minerals. There's an iron carbonate and there's some clay minerals. But the key thing is there's lots of porosity. The other thing is we know the minerals that are there now because we can quantify them. So the other type of rock to look at is the one on the right-hand side. This is an example of the seal that holds the fluids in the subsurface. Now, in oil and gas terms, we call it a cap rock or a top seal. It's exactly the same geometry we need to store CO2. We need a rock that's sitting on top of the porous rock to stop the CO2 escaping. So we've had to characterize that as well. And this is an example. One thing you'll notice is there isn't much white there, not much porosity. The bulk of it is a green color, which is a clay called smectite, which has very interesting properties. It expands when you wet it. It's very good sealing rock. So the indications are this is a very low permeability, a very good rock for holding the CO2 in the subsurface.